Okay, so quick review. We already did this right at the beginning of class. If you're in standard form, ax minus p all squared plus q. What are the vertex coordinates? P and q. We don't care about that. Axis of symmetry, I actually don't care about that either. Okay, so here's our question. We have something that's been launched into the air, projectile, and it's like a physics problem. It's described by the equation negative 4t squared plus 48t plus 3. Okay. They're going to ask us a whole bunch of questions. They're going to ask us max height. They're going to ask us when max height is reached. What's the height of the projectile at launch? And when does it hit the ground? You know what all these questions are actually asking? It's not, well, yeah, I guess it is physics. But they're asking for the vertex, they're asking for the Y-intercept, and they're asking for the X-intercepts. Because if you think about it, what type of graph is this? It's a parabola, right? It's the only thing we've studied, and it has a degree of 2, so you know it has to be a parabola. I'm going to do a quick sketch here, but we'll actually do the math and get the accurate sketch. Does this, or what's the Y-intercept of this parabola? 3, right? It's the constant term, so I can mark 3 there. Does it open up or down? So you know the graph looks something like this. Okay? Now, the only thing that's a little different here is we're not doing x's and y's. We're doing h, which represents height, and t, which represents time. T is where x's normally are. That means your time is along there. And y, or h, the height is where y usually is, so it's on this bit. Okay. Before we actually answer these questions, if I said, where is the max height? What point am I looking for? I'm looking for that point right there, which is the vertex, right? So when they say find the max height, they're saying find the vertex. When they say what was the height of the projectile at launch? Okay, right before you throw it in the air, you launch it into the air, what is your time? 0, right? So what am I really looking for when I say what is the height of projectile at launch? T is equal to 0, which is the Y-intercept. We can answer that right now. What is it? 3. What are the units? Meters. We're in meters. So 3 meters. And then when they say, when does the projectile hit the ground? What points am I actually looking for on that graph? The X-intercepts, because that's when it hits the ground, right? So this is the X-intercepts. This is the same question on the last one we just did, on the question 3 on that sheet I just gave you. Essentially asking all the same questions, except they've reformatted it into some sort of physics problem. Okay, so we want to find the max, so we got to find the vertex. So we have to complete the square, i.e. put it into standard form. So what do I do first to this equation? Take out a negative 4, right? T squared minus 12t plus 3. Now what? Yeah. And so half of 12 is 6. Squared is, well, negative 6 squared is 36. So plus 36 minus 36 plus 3. Which one comes out? Negative, what do you have to remember? Multiply by -4. 36 times -4, or negative 36 times -4 is? 144. So it's positive 144. And now you just factor the brackets, which we know are going to be a perfect square. So it's t minus 6 all squared plus 147. So what are the vertex coordinates? 6 and 147. So what's the max height? 147. All right. So B, let's look at B here. Find the height of the projectile 3 seconds after launch. What are we going to do there? Sorry? Divide both by 2. Divide what by 2? What? What is this? This is t is equal to 3, right? And if we know the equation, either this one or this one, it's the same thing, just put t is equal to 3 into it and solve it, right? So if t is equal to 3, it doesn't matter which equation you put it into. If you put it into the original or to this one, which one do you want to do? Okay. I'm going to put it into this one because it feels like it's less work. All right. So the height is going to be -4, 3 minus 6 all squared plus 47, or 147. What's 3 minus 6? -3. What's -3 squared? 9. What's 9 times -4? 9 times -4. What's 9 times 4? Okay, so it's -36 plus 147, which is 111. So at 3 seconds, when t is equal to 3 seconds, I'll just mark 3 seconds, it's saying this number is 111. That's how high it is. All right. When does it hit the ground? I.e., what is this? Oh. What is this point right here? How do I find that? How do I find this point? So you set the whole thing equal to 0, the height, and it's not going to factor, so you're going to have to quadratic. You're going to have to do this on the test, so you might as well learn to do it now. So you get this. All right. I'm going to do it, but I'm going to freeze it so you can't watch it, so you guys have to do it on your own. Because I'm going to ask you to do this on your test on Monday. And the quadratic equation is up there. People get it? All right, give me another couple minutes. There's your two answers. Negative 0.062 and positive 12.06. Which one do you ignore? The negative 0.62. Why do we ignore that? What is this? What do these represent? Time, right? Can you have negative time? No. They're here?
Yes, they are.
Oh my gosh.
Mediums?
Thank you very much.
Welcome. Aren't they fun?
I'm not going to wear mine to school.
That's fair.
But that's awesome.
Yeah.
Thank you.
You're welcome.
That's so
I'm
cool.
so excited that they came in.
I know. I was going to send an email saying what's going on with them, but.
Yeah. I thought they weren't even going to come until like next week, but
That's
awesome.
I know. I'll put it like either there or there. One of those spots I'll put it. But I should have ordered 3. I kind of want to wear one.
Yeah.
Maybe I'll wear it for the summer and then put it up. I don't know. We'll see. All right. Thank you. So negative 0.062, you ignore it because you can't have negative time. Therefore, the answer is 12.06. Is that okay? Where did people go wrong? This is the time. This is, 12.06 seconds because it represents this number right here would be 12.06 seconds. So it's in the air from here to there, 12.06 seconds until it hits the ground. The negative 0.06 or whatever is this number, but that's like negative time. All right, so it doesn't make any sense, so we ignore that number. This part of the graph doesn't make sense. So, all right, is that okay? It's the exact same question I asked you at the beginning of class, just put into a word problem. You don't want a word problem? All right. I think that's all I'm gonna ask you. All right, you know what? That's the only example I'm gonna do. I'm gonna ask you to do question number uno, please. Sorry? Yeah. Question number 1.